Okay, Aubrey, we are on chapter 3 review. We're starting at 16. Always, sometimes, never. There's 3 questions. Always, sometimes, never. So here we go. 16. A line contains exactly 1 point. Always, sometimes, never.
Sometimes.
You have to have 2 points in order to make a line, right? I have to have a start and an end in order to make a line. So never contains just 1 point and only 1 point, right? Okay, never. Any 2 lines, L and M, intersect. Always, sometimes, never. Sometimes. Sometimes they intersect, sometimes they don't. If they don't, they are what kind of lines? Or skew. They could be parallel or skew. What's skew again? Like in 3 dimensions. So like this line and this line, right? They're not parallel, but they're like 3-dimensional. They're like not even on the same plane, right? Okay. So this is sometimes. Sometimes they intersect, sometimes they don't. Okay, if points G and H are contained in plane M, what does that mean? Contained in plane M? Like they're on top of this plane. So I have a plane and I have 2 dots, right? Like this dot and this dot, right? And GH is a line that goes through those 2. Then it is perpendicular to the plane. What's perpendicular plane mean? Like sticking out of the plane. If those 2 dots are in there, does the line, will it be perpendicular? No. Always, sometimes, never. Like that's not going to work. He can't just pop out of the plane. He would be like on top of the plane. Like there's no way he can stick out of there. Okay, good? All right, are we ready for proofs? Colton, your phone should be back. Go put it away, please. Proofs. Now, the way that I grade proofs, this one has like a bunch of parts to it, like 7 parts, right? You should at least be able to get some of them, because what should be the first reason that you put down? If you don't have that figured out yet, you're behind. Given should be the first one. You get points for that. Did you know that? You get points for given. All right. It says that PR, this length is the same as QS. Those little, like 2/3 of the way, those are the same, right? They want me to say that this guy is the same as that one. Does that like equate? Does that like make sense that that would be a thing, right? Because they share the QR, right? Okay. All right, let's write down what we've got.
Therefore, the middle would be.
The middle should be the same, right? Okay, hold on. Just wait a second. You're getting ahead of the game. We know the first one's given, right? How do I go from A to B? Yeah, I just take the congruent off and make them equal. So, definition of congruent. It's the same thing as what they have down here. Definition of congruent segments, or just definition of congruent. I'm just going to use the symbol. There you go. Okay? Do we know that?
No.
Sure, definition of congruent. Just takes the congruent and makes it equal, right? Okay? All right, next thing. Okay, pay attention to this next one. PQ plus QR equals PR. PQ plus QR equals the whole thing. I'm adding segments together. That's segment addition postulate. Oh, but look. The next one is also segment addition postulate.
It's QR plus RS equals QS.
Yeah, I like it. So like this little piece right here, that second piece, he is 2 pieces added together. That's QS. I can't see my thing anymore. QR plus RS.
You put QR on there first.
Yep, it's supposed to be PS.
Oh, it's supposed to be QS. It's supposed to be QS at the end, right? QS? Yeah. I can't do that. Okay, there you go. Segment addition postulate also. I'm adding segments together, right? That's segment addition postulate. That is also on your blue sheet. You get to use your blue sheet on Thursday. Your blue sheet and your note card. Yeah? Those 2 things? Okay. All right. Now, how did I go from like these previous steps to this one? PQ plus QR comes from here, and QR plus RS comes from here. How do I know that? Hold on. How do I know that these 2 are equal? Because these 2 are equal, and you're right, substitution, property, whatever, just substitution, okay? Okay, now they're subtracting. You're taking away the QR. We're subtracting the QR off, right? So, PQ equals RS. Okay, and then also, you should be able to figure this out. What should your last step always be? This part right here, PQ is congruent to RS, except I have had people do this before. Don't be this person. Don't put prove as your reason, right? I've had people do that before. The first step you're given is your reason, but the last one, prove, is not your reason, right? Okay. I feel like a handful of you guys could get this by yourself.
No problem.
Yeah, I think you could. Okay, what were you saying, Dylan? What?
How is F subtraction property if it's an equal sign over there?
Because you're subtracting the QR from both sides. Do you see that? Yeah. Yeah, you're fine. You're fine. Good question. Okay, questions about the proof. I feel like a handful of you guys could get that by yourself. I feel like you could. I think Jordan could. Jordan could definitely.
Jordan is very much.
Kellen, were you watching this last one? Okay. All right. Okay, here we go. Ready? 20. Angle 7, they say, is 5x plus 5. Angle 8 is x minus 5. What do we know about 7 and 8? They're a linear pair. They add up to be 180. Okay, so if I put them together, 5x plus 5 plus x minus 5 equals 180. Okay, let's combine like terms. Yeah, the 5's cancel. 6x equals 180. Kellen, Dylan, shush. 6x equals 180 divided by 6. X is how much? 30. Do they ask for find the measure of each numbered angle? So that means we have to plug it back in. If I plug 30 back in, 155 degrees, and 30 in here, minus 5 is 25. Shush. Be quiet. No. I don't think so.
Okay, quick call me name.
Okay, shush. Next, 21. 5, 6, 7, 8. They have them labeled. What do we know about them? 5, 6, 7, 8.
You have to name the center.
They all add up to be 180, right? They're all like, kind of a linear pair, but a linear pair is only 2, so they're like a linear quadruple or whatever, right? Yeah? Oh, yeah. Supplementary angles. Supplement theorem, whatever. Okay, what about 21? Is that supplement theorem also? Yeah, because they all add up to be 180, right? Sure, supplement theorem. Okay, so I'm adding them all up. Can we cheat a little bit? Let's add these together. What's 5x, 4x, 10x, and 12x? 31x. Okay, and then let's combine the other terms. So 6 and negative 12, are those the only other ones? Minus 6 equals how much? 180. Okay, so I'm just combining all the stuff, but I'm not.
We don't know what 6 is.
Hold on, just wait. Add the 6.
I'm so confused.
If I add 6 over 186, divide by 31.
It's gonna be 60.
No, just 6. Just 6. Okay, but then we got to plug them all back in.
Wait,
60, 60, 30, 30.
why is it?
Okay, if I plug 6 in, angle 5 is 30 degrees. I'm gonna label them here. Okay, angle 6, if I plug 6 in, 4 times 6 is 24, plus 6 is also 30. Okay, if I plug 6 in here, angle 7 is 60. If I plug 6 in here, 60 also? Yeah, there you go. Okay, supplement theorem. All right. Now, 22. We have 11, 12, and 13, but they only give me labels for 11 and 13.
Vertical angles.
Nope, 11 and 12 are vertical angles.
Oh, I thought it said 12. My bad.
They're supplementary. You could say supplementary, or you could, in this case, say linear pair. Supplement theorem. Okay, so if we add those two together, they are
180.
180. 11x,
21.
10x plus 12, 21x plus 12,
Plus 12 equals.
minus 12, minus 12. 21x equals 1. Kellen, you have got to be quiet. I have been sitting here this whole time telling your whole back row, except Macy and Jordan, and Jacob over here, to be quiet. Just listen.
It's Jacob.
And Colton over here. You guys are all chit-chatting back there. Be quiet. No, there's no please. I asked please 4 times ago. Now it's do it now. There is no please about it. Or I'll just send you, and you can go sit in the office and do this by yourself. Be quiet. I can only be so patient.
8.
Thank you. X is 8. Plug it back in. If we put 8 in, angle 11 is 88. Angle 13, if I subtract from 180, that is 92?
Yeah, 92.
92 degrees. Got it? Yes?
Yep.
Okay. Jack had that answer a long time ago because everybody won't shut up, right? Okay.
Well, Jackson.
Woo! Right. Backside. What do we know about this diagram? One thing that I see.
This
Parallel.
Only this one and that one are parallel, right? The other two are not parallel. They don't even look parallel, okay? Maybe they will end up being parallel according to the numbers, but they don't look parallel right now, all right? So let's, they give us 2 angles. They give us that angle 9 is 80 degrees. And angle 5 is 68.
Oh, is this like what we do on that?
All right, yeah. Okay, so now I'm looking at angle 12 first, okay? So if I'm doing angle 12, we know it has to be 100. Why?
Because it's,
Because with 80, it is supplementary, but also it's a linear pair. So I'm going to go angle 12 is 100 because it's a linear pair. Okay, let's go to 24. We're going to angle 1 now. Okay, angle 1, this guy. What is he? 80, because with the 80, the original one that I was given, he is corresponding. They're corresponding angles. So 80 degrees, corresponding angles. Got it? Okay, now angle 4 is
100.
this guy, 100. Angle 4 doesn't really have anything in common with 80, right?
Angle 10.
But
Linear pair with
4 and 1 are a linear pair, or you could say 4 and 12 are corresponding. So whichever one, I don't care. Angle 4 is 100. I'm just going to say that it's a linear pair with angle 1. LP with angle 1. Sure.
368 because it's all interior.
Okay, hold on. Angle 3.
68, all interior.
No. Angle 3.
80.
Ah. Oh. I'm gonna use your example. Can I use your example, Colton? Okay, Colton says angle 3 is 68 because these alternate interior angles, right? Except for, hold on, that was a legit question.
I see what I did wrong.
Because these two are not parallel.
Yeah, I realized.
So you have to compare this guy to this one. These are alternate interior angles, the 3 and the 80, okay? So I'm glad you did that though. Angle 3 is 80 because he has alternate interior angles with the 80. Got it? Angle 3 is alternate interior angles, okay?
we do linear pair with 4.
You could say linear pair with 4. I don't care. Either one. Whatever.
68.
That's fine. Okay. 7 is 68. How do you know?
Vertical angle.
Vertical angles. Awesome. 7 is 68. Vertical angles. Okay. And then 28 is 16.
92.
16 is 92 because he is what?
Consecutive interior.
Consecutive interior with the 68 with angle 7, right? Okay. So 92. That's not 92.
No.
No,
It's 112. 112. I can't math. 112. And they're consecutive interior angles with angle 7. Okay, consecutive interior. Got it? Good? Beautiful? All right, I will do one of these with you and you do the other one by yourself. They want parallel, perpendicular, and neither. Let's talk about it. Parallel lines have the same slope. You're right. You didn't know what I was asking, though. That's fine. Perpendicular lines have the negative reciprocal slope. Okay, so MN go together, these two go together, and then RS go together. Woo, woo. RS go together. Okay, how do I find slope? Rise over run. Y2 minus Y1, X2 minus X1. What's your Y2 for MN? 4 minus 3 over 2 minus 0. 4 minus 3 is 1. 2 minus 0 is 2. 1/2. Okay. RS. Carson, are you writing this down? Simon, are you writing this down?
I go back home.
Yeah. Y2 minus Y1. RS. 4 minus
Oh my gosh.
1.
It's parallel.
8 minus 2. 4 minus 1 is 3. 8 minus 2 is 6. That is 1/2. They are
Parallel.
parallel. Okay, you start the other one. I'll give you 30 seconds and then I'll go.
What?
Well, it's enough time for like me to start though, because I can't get the answer instantly. Okay, so find your slope. Y2 minus y1, x2 minus x1.
When are we gonna quit?
When I say it's time to quit, we have a lot of time left. That's 15 minutes that we could be doing something. Okay. Did you find the answer? Jace?
I did.
You got the answer? I see something. But I don't know what it is.
And go
Okay.
the other.
Did you put down parallel or perpendicular? Yeah. I see it. I see it. Okay, ready? 30? 5 minus 3 over 0 minus negative 1 or plus 1, right? 5 minus 3 is 2 over 1, so 2 is your slope. Okay? Second one? Negative 1 minus 1. I'm trying to give the answer. 6 minus 2, so negative 1 minus 1 is negative 2 over 4, which is negative 1/2. Those are, in fact, negative reciprocals, so they are perpendicular. Does it have to be one or the other?
No.
Parallel or perpendicular? Most of the time it's neither, right? The lines are just intersecting. Okay? By the way, what does perpendicular mean?
They're intersecting at one point.
They're intersecting at one point, but these intersect at one point. But those aren't perpendicular. They intersect at a 90-degree angle. They have to intersect at a perfect T, right? Do you know the symbol that they use for perpendicular in your book?
One line, it's like an upside down.
Upside down T like this. So if like AB is perpendicular to CD, that's the symbol that they will write. What will they write for parallel?
2 lines.
Yeah, if AB is parallel to CD, that's the notation that they will use. Got it? Beautiful, beautiful. Okay.
No more.
All right. Let's do these last 3 and then we'll be done.
Yay.
We'll save the other 3, the other sum for tomorrow. Okay? I want to graph it. I want to graph this thing. Okay? And I want it to have a slope of 3 that goes through 6, 2. Where do you start?
6.
You start at 6, 2. 2, 4, 6, up 2. I want it to go through that dot and I want to have a slope of 3. What's 3 as a fraction? 3 over 1. Up 3 over 1. Up 3 over 1. Down 3, left 1. And this is what he looks like. Yeah? Okay, really quick. What if I say write the equation of that line? How do you do that?
Y equals 3x.
Y equals mx plus b. We know that the m is 3, so 3x plus b, right? Okay? And then I'm going to plug in 6, 2, right? 2 equals 3 times 6 plus b. 3 times 6 is 18, and then,
Negative 16.
Tracked out.
yeah, b is negative 16, exactly. Yeah.
Oh, yeah, it is nice.
So y equals, final answer,
It took me a second, really.
3x
3x
minus 16. Perfect. There he is. Got it? No, they didn't ask, but I'm mic'd on the test. Do you know, like, as long as you know how to do that, you're fine. Okay? I'm just getting you ready. Okay, 32. I want it to pass through this thing, but be perpendicular to this guy, right? So I'm going to plot these points. 0, 5 is this guy right here. G is 3, negative 1. So here is my line. And then I have 8, 5. 2, 4, 6, 8, 2, 4, 5. And I want it to be perpendicular. That means at a 90-degree angle, right? Is that where he crosses? Does he cross over here? I don't know. I don't know.
Whoa.
I don't know.
That is not perpendicular.
Is that perpendicular? That's not perpendicular?
That is.
Okay. All right, so let's do this.
It's the other one.
I want to find the slope of this line. Rise over run. He's going down 1, 2, 3, 4, 5, 6, right? Down 6 and over 1, 2, 3. So what's his slope?
-2.
Negative 2 is his slope. What's the slope of this line going to be then? Positive 1/2, right? So I go up 1 over 2, right? Or I could go down 1 left 2, down 1 left 2, down 1 left 2, down 1 left 2, etc., right? Okay, good? Like that? All right, if I ask for the equation of the line, y equals, what's the slope?
1/2.
1/2 x plus, you can find b on here. B is the y-intercept. It's at 1. Awesome. Or you can plug the point in. Whatever. Okay? All right? Good, good?
That one don't
33 doesn't come out nice. Okay.
32 doesn't come out.
32 doesn't? Oh, like they don't cross at a nice point. Right. But you're not having to find the distance, so it doesn't matter. Like you would in the bottom one. Okay. And passes through 6, 1, 2, 4, 6, 1. And it is parallel to 2, 1, and 7, 4. 7, 2, 4. This line right here. Okay? So if I want him to be parallel, he's got to go like this also, right? Whoop. Okay? All right, I want to know the slope of this line right here, the red one. He is up 3 and over 5, so 3/5, yeah?
Yes.
Okay, so this guy has to also be 3/5 because he's parallel, right? Y equals 3/5 x plus b. I don't know. Does he cross it -3? I don't know. Let's put plus b. What point are you going to plug in? This is gross.
Go to -5, 3 slope off of that. That way it's perpendicular. You know the shortest position.
No, he would be down 3 and over 5
What?
and down 3 and over 5. He's going to have the same slope.
Offensive.
Yeah, but like to find the distance of the.
I'm not trying to find the distance between them. I'm just trying to graph the thing.
No, that's it.
Yeah, you're not having to find the distance. Okay, so how do I find B?
Plug in a point.
Which point? There's 3 of them. Do I get to choose?
Blue line.
The only point I get to plug in is 6, 1 because that's the only one that I know lives on this line, right? Okay, 6, 1. So I'm going to plug 6 in here and 1 in here. That's gross.
1 and 3/5, or 1 and
3/5 times 6.
-2/5.
This is 18/5, which is 3 and 2/5. Is that true? 3 and 3/5. 3 and 3/5. If I subtract 3 and 3/5 from 1, what's 1 minus 3 and 3/5? -2 and 3/5. Yeah? So y equals 3/5 x minus 2 and 3/5. So he should actually touch like right here. Right there. Right there. Gross. Disgusting. Okay? All right. For homework, I want you to attempt the next 3. Those ones are not bad. You can do those. And you've got like 15 minutes left.
So no 37.
Okay? We'll do 37, 38 tomorrow, but together. How about that? And then we will do some note card stuff or some whiteboard stuff tomorrow. We'll finish the last 2, do whiteboards, and then we will test on Thursday.
Yeah.